All right. So if you're viewing this problem and you haven't seen me work through this entire problem in the previous video, I would say go back and look at that, because what I did when I worked through this the first time, as I mentioned, I'd come back and show an alternative method for expanding this. So that's what this is. This is sort of the master's class on something here. It's super tricky, but something that's kind of interesting, and I want to show you this. So when it's our job to start multiplying all of this together, it's kind of daunting because there's a whole bunch of terms here, right? This is really x, and this is x plus 1. I can multiply these together and get x squared plus x. But what can I do with this entire thing? Okay, now again, to the untrained eye, you might not see this, but take a look. When you see the three terms that are here, instead of looking at it as three terms, look at it as these two parts together. And I have that in the front, quote unquote, the front of both of these binomials, or I guess they're trinomials, right? Because there's three terms. But if we look at this, all right, and we enclose these and say this part is the same, and then you look in the back and you notice, or the quote unquote back of each of these quantities, and we have the same part in the back. These are separated by a minus and a plus. So even though these are not binomials, we can still view them as conjugates, okay? And more precisely, they are complex conjugates because we have an imaginary part and we have a real part. And when you multiply complex conjugates, we've talked about this before, okay? Let's make it more simple. X plus 2i and x minus 2i, right? A real part and an imaginary part. The product of complex conjugates is the sum of the squares of these parts, okay? So what we can say here is this product is really x minus 3 squared plus, and then we can say 1 squared, or we can say negative I squared. So here what we're going to say is just 1 squared, right? We only square the real number part, or the real number coefficient, to get this number. So what's the real number coefficient for these i's? It's a 1. Okay, so we're squaring that 1. So if you saw in the previous video, what we did with this is we did all of this multiplication of all of these terms, okay? But really, one way to look at it is as complex conjugates producing the sum of squares. Now when you look at this, x minus 3 squared, okay, is probably easier for some of you. And some of you have picked up on this shortcut by now. Anytime I square a binomial, okay, square the first part, square the second part, multiply these two numbers together and double it. Every single time you have to square a binomial, a real number binomial, not complex. Let's stay with real numbers. Anytime we have to square a binomial, square the first part, square the second part, multiply these two things together. That would be negative 3x, and then double that, it would be negative 6x. So this squared binomial ends up being this. 1 squared is 1. And then we end up in the same place we were at in the previous problem, where we multiplied all those terms out, and then we crossed off the ones that they had in that were opposites, and we combined the ones that were alike, and yada yada yada, and we ended up with this. Okay, this is a shorter way to get to that, but it's super tricky because we're trying to identify where the conjugates are. All right, so not necessarily something you have to do, just something interesting to keep looking for these conjugates as they pop up when we're multiplying binomials or trinomials in the future.